Hi class, today we're talking about similar polygons, and you may have learned before that congruent means same size, same shape, and similar means that they have the same shape but a different size. That's kind of the basic definition of what this is going to be. We're going to add on to it for what you need to know for this class. So you need to know that two polygons are similar if and only if, meaning that if they're similar they will be this, and if they're this they're similar. If all their congruent or corresponding angles are congruent, and all the corresponding side lengths are proportional. So if they were both if both of these things were congruent, then they'd be congruent polygons. When the angles are congruent and the sides are proportional, that makes them similar. So looking down here, these two quadrilaterals would be similar, and it says that in the directions that ABCD is similar to WXYZ. And just when we did our congruency statements and you had to like match up the angles in the same positioning, you need to do the same thing here. So angle A is congruent to angle W because they're in those same corresponding spots and all the corresponding angles are congruent to each other. So I can go through these. Angle B corresponds with angle X, so I can say that those angles are congruent. C and Y are congruent, and angle D and angle Z are congruent also. And what we have down here is this is called a similarity statement. Just like when we did our congruency statement and you had to line things up, you're going to have to line things up here too. And just in case you didn't know, that one squiggle means that they are similar. So just a symbol for that. Okay, so their corresponding sides are not the same length, but the corresponding sides all are proportional, or we can say that they have the same ratio. And if you look here, AB corresponds with WX, and if you actually find that ratio 15 to 5, that would simplify to be 3 to 1. The other sides, BC, corresponds with XY. So those are proportional, and that ratio is also 3 to 1. For CD, that corresponds with YZ. And the last one is DA, and that corresponds with ZW. So the directions for the work will ask you to do these things. They'll ask you to list the corresponding angles that are congruent. They'll ask you to write out the corresponding sides, and you're going to write that those are proportional. And they might ask you to write the similarity statement, and that's just how these are going to be. The next example is actually, I think it goes over that exact same thing. Yep, so this is exactly how it'll look. So it says here, these triangles are similar. That squiggle means similar. And I'm just going to make sure this is ABC, and it goes around in that order, and RST, so it kind of just looks like it's a translation, but it's gotten a little smaller. So list all the pairs of congruent angles. So I'm going to say that angle A is congruent to angle R, angle B is congruent to angle S, and angle C is congruent to angle T. And then write a proportion that relates the corresponding sides. So this proportion, I would say that AB is to RS, and just, writing out those sides. That's going to equal BC to ST, and then lastly CA to TR. And this would be everything that I'd be looking for if that's what the directions said. The next thing says we want to find the scale factor, and if we're looking for scale factor, what we're doing is we're writing the ratio of all of the lengths. Let's say ratio of the lengths of the corresponding sides. And usually whenever you have similar triangles or similar polygons, it'll ask you for what the scale factor is. That scale factor earlier in the page was 3 to 1 because all of those ratios simplified to be 3 to 1. And one thing you can do is you can tell if things are in fact similar if they all have the same scale factor for their sides. So the next example here, I know it's not written out, I thought I would just kind of explain it. This is something that I've had to deal with in my real everyday life. I don't usually get pictures printed, but when I do, there's some different size options, especially for the ones that I want to get framed. And some common size options are 8 inches by 10 inches. So let's just say that this bigger picture here is an 8 by 10. And let's say that these smaller ones, another kind of common size, is 5 by 7 inches. And I want to tell, are these similar? Because if they're similar, you could just enlarge one or reduce one without having to like crop it at all. And if they're not similar, that's not going to work out as well. So looking at this, I want to look at what these ratios would be. So I would say that this 5 corresponds with the 8. So is 5 to 8, is that the same ratio as 7 to 10? And I know that it's not, but just in case you can't tell if it's not, here's a couple ways that you could figure it out. One thing that you could do is you could just take each of these and divide them. So if I had, let's see, 5 divided by 8, 0.625, and if I look at that other one and I take 7 divided by 10, that's going to be 0.7. So these are not that exact same ratio, so I would know that these are not similar rectangles. Another way that you could do this, and if I only had 2 things, this is probably the method that I would do, is you could cross multiply, and if you cross multiply you should get the same thing. So here I have 50, and since 50 is not equal to 56 when you cross multiply, that's just another way to know that those ratios are not the same. So there's a couple different methods for you. It doesn't matter which way you use when you just have 2 of them, but if they were to have the same scale factor, then we would know that they are similar. For this one here, this is another one that it says, are these similar? If so, we want to write a similarity statement and give the scale factor. Well, looking at this, I do know that all of those angles are congruent, even though only 2 of them are marked. If you remember from a previous chapter, we have the third angles theorem. I think it was in section 4.3, where if you have 2 congruent angles congruent to 2 in another triangle, those third angles have to be congruent. So now I just need to check and see if these sides are proportional. And sometimes this can be really hard to tell like what sides correspond, especially when you don't have a similarity statement because we're being asked to write it. So what I'm going to do is I'm going to look and see, okay, this side, this 12.5, is the side that's contained between the angle that has 1 mark and 2 marks. So the side that's going to correspond to that is RS, and that side is 10. So there's one ratio. I'm going to write the ratio of these other sides now. So this 11.5, another way you could kind of tell is this is the shortest side in this triangle, and that one's going to correspond to the shortest side in the other one, so 9.2. And then lastly, 15 corresponds with 12. So I can't really cross multiply for this one like I did the last one. So what I would do is I would use that calculator trick where I just divide each of these and see what I get. So I have 12.5 divided by 10, so that's 1.25. If I do 11.5 divided by 9.2, that's 1.25. And then lastly, if I do 15 divided by 12, that is also 1.25. So since all of those have a ratio of 1.25, I can say that yes, they are similar. I can write my similarity statement, so I would write that triangle, let's say NQP is similar to, and if I said NQP, I just need to make sure I go in kind of that same order, so the one with 1, 2, and then 3 arcs. So triangle RST. And then the last thing it wants me to do is write my scale factor, and I always want to write that as a ratio. So even though when I divided those I got each one to be 1.25, I just want to change that back to a fraction, and it's always, you know, you have to write it as an improper fraction if that's the way that it has to be. You could think about like dividing each of those by 3 to get that also. So either way you want that scale factor. And then your reasoning could just be like all the sides are proportional and all the angles are congruent. For this next one here, it says that we want to find what the variables are given that these are similar. So because we know that they're similar, we know that the sides are proportional. And again, it might be helpful to you to either like locate where the segments are that are congruent, or sorry, are similar, and that correspond, because it's kind of hard to tell maybe based on this picture. So we have JM here, and I'm going to use different colors. If you have different colors, that might work out well too. So JM corresponds with QT. So I actually know what that ratio is. That ratio is 4 to 2, and if you want to change that to 2 to 1, you could. And then for this next one, let's find LM. So LM corresponds with ST, so that's this one here. So I had said before that there's more than one correct way to write this proportion. And there is. If you do it the same way as me, that's fine, but you could get the same answer a different way also. So we have 6x minus 3 over 3, and those are going to correspond. So what I'm going to do is I'm just going to solve this for x. When I cross multiply, I get 12 equal to, and make sure that you distribute that, 12x minus 6. When you add 6 to each side, you get 12x equal to 18. And then lastly, you should get x to equal 1.5. I have had students tell me before that, well, they just know that this is twice as big, so they know that this side is going to be twice as big. And that works out fine if you want to do this one that way. They won't always work out that way, so I just want to give you a strategy that will work all the time. So then to solve for y, I'm going to go back to my 4/2, or 4 to 2, and now I'm going to set that up with these sides. So that's going to be 3y minus 2 over 5. So I'm going to cross multiply. This is 20. This one here, when you distribute, you get 6y minus 4. Add the 4, so 6y equals 24, or y equals 4. So I've successfully solved those. If you want to plug those in as a double check, that would be a good thing. Remember that these are not going to be equal. You need to remember that these are proportional, as is almost everything we're going to do in this chapter. So we're not just setting these things equal, we got to make sure we set them up as a proportion, and then we can cross multiply to solve. And then the last thing for this section that you need to know is we need to know that the perimeter of similar polygons is the same ratio as the scale factor. And this can just save you some time. Instead of maybe finding all of the different sides, if you can just find the scale factor, you can give the ratio of the perimeters also. And this next example here demonstrates it. It says these two quadrilaterals are similar. Find the scale factor of this one, MNPQ, to that one. So this is another thing that you just really got to make sure you pay attention to. It wants the scale factor of that one to the other one. So you need to make sure that you put the number that corresponds to this one first. So I need to look and see which one of those numbers corresponds with the 4. The 4 is WX. So the side that corresponds to that is QM. So QM is this one here. And again, sometimes that might just be kind of hard to tell, you know, if it's rotated or reflected or how that's supposed to look. So I'm going to say that this is 8 to 4. And when I simplify that, and you're always going to want to simplify your scale factor, the scale factor is 2 to 1. So you could write it this way, or you could write it any other way that we usually write scale factor, or any ratio. And then we want to find the perimeter of each polygon. So the perimeter of this one's pretty easy. I'm just going to add up all those sides. The perimeter of this one is 34. So now what I need to do is find the perimeter of this smaller one. And I could set up 3 different proportions and find each one of those separately, but that's going to be more time than I want to spend, and I don't actually have to do that because the ratio of the perimeters is going to be the same as the scale factor. So if the scale factor is 2 to 1 and this perimeter is 34, what I can do is I can set up a proportion, or maybe for this one you can just kind of tell. But if you can't, you can always set up a proportion and cross multiply. So I have 34 equal to 2x, or I'm just going to divide each side by 2. So that other perimeter is going to be 17. And I don't have any units on that, so I can just kind of leave that as is. And that is that. I hope this helps, and I will help you guys with this in class.